Hello, everyone, and thank you for joining us today for our Hoymiles HMS Series Microinverter Installer Training webinar. Just a few quick items before we get started. During the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, feel free to use the Q&A button at the bottom of your screen to type in your questions. They will be monitored. And it is my pleasure to introduce today's presenter, Jeffrey Jones. Jeffrey is the Customer Engineering and Support Operations Team Lead at Hoymiles. He brings 5 years' experience in the solar industry, along with 6 years of experience as a commercial and industrial electrician. So thank you for joining us today, Jeffrey. Over to you.
Thank you. So I'm going to go ahead and get started right away here. Thank you for the introduction, by the way. And let's see, there we go. Oh, 2 pages. There we go. Okay, so we're going to start with some background of Hoymiles as a company. Hoymiles was established in China in 2012. We have over 1,600 global employees, 31% of which, more than 31% of which is R&D staff. We have 4 manufacturing bases, and we're installed in over 190 countries and regions around the world. We are the #2 microinverter supplier globally as of 2023, which is the last statistic that I've seen for that. We have 12 plus years. That this page is a bit outdated because it's not 2024 anymore. 14 plus years of open energy adventure. In particular, I want to sort of look at this timeline and talk about some things that aren't on it. So in 2020 is about when we entered the North American market, and that's not on this slide. You may notice some of these slides are not so much focused on the North American market as they maybe ought to be. But around 2020 is when we entered the North American market. At that time, we brought over the MI series, which was slightly older, and shortly thereafter, we brought over the HM series of microinverters. Around 2022, 2023 is when the HMS microinverters that we're going to be talking about today, the newer product, have been introduced to North America. We have regional business headquarters in North America, Europe, and 2 in Asia. Manufacturing, local manufacturing, in fact, for our HMS series that we're focusing on today, takes place in Monterrey, Mexico, for the North American market. And we do have our distribution center here at Los Angeles. Obviously, we have a North America support team, technical support team, which I'm a part of. And we will be making sure that everybody here has contact information for the North America technical support team by the end of the webinar presentation. So again, I wish I had fixed this. The R&D is very important to us at Hoymiles. We've invested heavily in R&D. 13% of our revenue, at least, is allocated to research and development. A third of our workforce is R&D, which has allowed us to reach some pretty impressive milestones, like our 97.5% peak efficiency, 97% CEC efficiency. And also we've earned ourselves some honors and awards along the way. We have a global supply chain capacity of 5 million microinverter units per year. Average lead time from China, if a product needs to be ordered from China, is about 3 weeks globally, including here in the US and Canada. Anything that we have in our local warehouse in LA typically arrives within about 3 days when a distributor or a large customer places an order. Let's see, comprehensive quality control. We're compliant with global standards for informational systems and power electronics. We have a 96% plus customer satisfaction. rate and 48 hours of problems resolved globally. That is actually much better in the North American market. Here at Hoymiles USA, we pride ourselves on our customer support. We have a small team of very knowledgeable customer support representatives here at Hoymiles North America. We actually, every one of us has in-field experience doing installations with these microinverters. So when you speak with a Hoymiles customer support representative on the phone or by email, you can be confident that we know what we're talking about. We've been there. We've been on the roof, and we should be able to help you out with whatever problems you may have. We do offer field service for our customers that need it. Often that comes in the shape of installer training for maybe your first installation. If you work with us, work with our sales team, and schedule with our support team, we can have one of our support technicians out on site with you for your first installation to help sort of make sure things go smoothly and get your crews on the ground trained to work with our products, even though they are very simple, plug and play for the most part. Let's see. We are committed to green development. Global carbon reduction is the name of the game. Solar is a green industry, and we definitely prioritize that in our manufacturing as well, with low carbon production systems and a people first policy for our global structure, as well as data and privacy warnings and notices before you log in everywhere. Makes things clear what we are and are not taking and sharing. And these products that you see here are actually, again, largely not available in the North American market. Our utility scale products are only in the Asian market. But we're going to be focusing on microinverters and the residential market with a little bit of talking about the commercial or three-phase microinverters as well. So here we are, the meat and potatoes of this presentation, the HMS Series Microinverters, coming in flavors 1-in-1, 2-in-1, and 4-in-1, from 350 watts per input on the 1-in-1 and 2-in-1 there, HMS 350, HMS 700 being the 2-input version of that, all the way up to 500 watts per input on the HMS 500, HMS 1000, and HMS 2000. So these HMS series microinverters, they use sub-1 gigahertz communication. That's one of the major changes that we brought with this product line. The HMS series, which again launched around 2023, I believe, early 2023 in North America. The sub-1 gigahertz allows these microinverters to have stable communication over greater distances and improved barrier penetration, especially for metal roofs. If you have a rooftop installation on a metal roof with the older microinverters, we often saw trouble with communication, especially just holding a stable communication was a challenge. With the older microinverters, those issues are no longer present, or very largely mitigated, at least. With the HMS series sub-1 gigahertz communication, it has about twice the communication distance that our older microinverters did, and greatly improved barrier penetration. We also have a low startup voltage on these microinverters, 22 volts DC to start up the microinverter. And that is actually one of the things that makes us unique to some of our competitors, is that these microinverters power on with DC power from the solar panels. AC power will not power on the microinverters, or I should say is not necessary to power on the microinverters. Which allows us to do some fun things as installers. You can communicate with the microinverters and get alarm codes. voltage readings. You can set firmware upgrades, change grid profiles, all of that before PTO is granted, before the disconnect is turned on. As long as the microinverters are connected to a solar panel and that solar panel is outputting at least 22 volts DC, the microinverter turns on and we can communicate with it and do everything we need to do. That low startup voltage, by the way, and I think we'll get another slide here that goes a little deeper into the specs. But that 22 volt startup voltage allows for the microinverter to start up when the sunlight is great enough for the solar panels to reach 22 volts. And then the microinverter doesn't shut down until I believe 16 volts. So in your early morning hours, it improves the stability of the microinverter, making sure that it stays on once it turns on in the morning. We have max input current and short circuit current up to 20 amps on certain of these microinverters. The lower wattage versions have 14 amp input current. Let's see, independent MPPTs for each input on these microinverters, including the 4-in-1. So the 4-in-1 HMS microinverters, they have 4 independent MPPTs. So you don't have to worry about one panel getting shading and that affecting even the panel next to it. There's no effect at all of like that when you have independent MPPTs like this. They are fully certified for UL 1741 and UL 1741 SB, and they come compliant with those grid standards by default. So yeah, here's some more features. Suitable for high-powered solar panels. Individual MPPTs allow for more accurate monitoring and greater data available to us as technicians and installers. Reactive power control compliance with UL 1741, UL 1741 SB, IEEE 1547, all of that controllable through the Hoymiles cloud interface to the ability to modify grid profiles to meet your local standards. Safer rooftop solar stations with PV rapid shutdown compliance should pretty much be a given these days. Rapid shutdown compliance is certainly something that microinverters are known to be able to do, and ours are no exception there. We have power outputs ranging from 350 watts to 2,000 watts, 350 watts in the 1-in-1 to 2,000 watts in the 4-in-1. So on the 4-in-1, that would be 500 watts per input. But still plenty of options to meet whatever needs you have necessary. And again, the sub 1 gigahertz communication allows for stable communication to the DTU, Hoymiles Gateway. Here we are, the specs. I'm not going to go into super great detail here because it would be a very long and boring presentation if I did. Excuse me. But we can point out a few things here. Number one, on all of our spec sheets, all of our data sheets for these microinverter products, HMS series, as well as our other microinverters, we have a commonly used module power right here at the top. So for the HMS 500, our most powerful 1-in-1 microinverter, we recommend using PV modules with wattages anywhere from 400 to 670 watts. Which breaks down to about a 1.3 DC to AC ratio on the top end, which is generally about as high as what we recommend. Maximum input voltage, 65 volts, although the MPPT voltage range here, you'll notice, goes from 16 to 60 volts. And again, the startup voltage at 22. So again, the way that's going to play out is in the morning time, the microinverter doesn't start up until 22 volts is reached by at least one solar panel. Then it starts up, and even if a cloud rolls over or something drops that voltage from there, it should stay above 16 volts and the microinverter will remain on. And on the top end, the MPPT voltage range up to 60 volts, whereas we have the maximum input voltage up to 65. The microinverter will not produce more power above 60 volts DC but will not alarm out and stop all production until 65 volts DC. So we do have that 65 volt maximum. Above that, the microinverter will alarm and not function properly. Whereas at 60 volts, you're just not going to see any more production for the more voltage above that point. Input currents here as well, listed on the spec sheet, obviously, as well as the short circuit current. And again, a one-in-one microinverter is only going to have a single MPPT. Let's see. Last thing I want to point out on this spec sheet, and we'll get to look at this for all of our microinverters. I believe I have on this slideshow as well, all of our HMS series at least, is the maximum continuous output current listed here at 240 volts on the first spot there, and 208 volt three-phase here as the second entry for each of these. And we've translated that down below here, maximum units per 10 AWG branch and maximum units per 12 AWG branch. So depending on which cable size, which wire size you're using, and whether you're using a 30 amp breaker or a 20 amp breaker, we go ahead and list the maximum number of microinverters per string on the spec sheet. So moving on to the 2-in-1 here, similar specs on DC input wise, you just have 2 MPPTs. So you can double the solar panels, obviously. Let's see. Anything else worth pointing out here? Yeah, our maximum units per number 10 branch and number 12 branch, follows that same. Oh, the efficiency over. Let me go ahead and move on to the next slide. The 4-in-1 microinverters here. These are probably our most popular. The 2-in-1 and the 4-in-1 maybe equally popular, but everybody always wants to talk about the highest output version, the HMS 2000, which is able to reach a CEC peak efficiency of 96.5% and normal MPPT efficiency of 99.8%, or nominal, I mean to say. With a nighttime power consumption on all of these microinverters of less than 50 milliwatts. So very, very low, certainly not noticeable on your power bill, the nighttime power consumption, because they actually don't turn on at night. They're connected to AC power, but without DC power, they're just not turned on, which is how we achieve that very low nighttime power consumption. Yeah, let's see. We only list the maximum units per number 10 branch on these 4-in-1 microinverters because you would just have so few of them on a number 12 branch circuit that most people don't use number 12 branch circuits for our higher powered microinverters like this, the 4-in-1s up to 2000 watts. Most people use the number 10 branch circuit. We do have both available though. So here's a diagram showing installation and trunk cabling for the 4-in-1 microinverters. This demonstration, this example uses number 10 AWG, even though it's, like I said, we also have number 12 available if you just prefer to use 20 amp breakers. Let's see. We have the trunk cable itself comes in pre-assembled lengths. You would purchase, I think they come in boxes of 20 or maybe 10, I don't quite remember, for the number 10 cable, pre-assembled. So you just line up your trunk cable along the rail. If you have to skip a spot because you don't have a microinverter to go there, or you need extra length to get to your next microinverter position, we have the port cap here, AC port cap for any unused T connectors. We do have this trunk cable in a 2-meter or a 4-meter length to suit those needs as well. And we have end caps available, although what most people do is open up the T connector here, the last one on the string, and simply remove the cable exiting that T connector. And we have another type of cap to plug that in to make sure water doesn't get into the connector as well. And then your AC end cable often is just the preceding length of cable on the trunk. that you would strip back and shove into your solar deck or junction box in order to make the joints and connect to the home run back to your breaker panel, combiner panel. You'll notice here also these red cables here, the DC extension cable here, are often necessary with the 4-in-1 microinverters. So if you're going up to your first Hoymiles installation with 4-in-1 microinverters, and you've got 4 solar panels all connected to one single microinverter, if you haven't ever tried to do that before, most solar panels don't have enough length on their DC cables to reach all the way back to a single microinverter for 4 of them to reach back to the single microinverter. So we do also have DC extension cables available. Those are Battery MC4 connectors, very standard, compatible with basically any solar panel. So we have a solution for that, and we don't typically have much trouble there. I do recommend using our pre-assembled DC extension cables, though. Working on the tech support team, I see plenty of cases where we have input issues, and people will call me up and say, "Hey, why is this one solar panel not working?" And I say, "Have you got on the roof yet? Have you checked it?" And they say, "Yeah, I'm up here now looking at it. It's got a DC extension cable." And I say, "Just replace that DC extension cable. 90% of the time that solves the problem if you have one panel out and it's connected with DC extension cables. Usually they're handmade or assembled at the field DC extensions that give people trouble, and our pre-manufactured DC extension cables, I think, are the best solution to resolve those issues. So again,
Jeffrey,
here, yes, please.
just before you move on to the next page, there was a question that came through in the chat on the last one, just about what happens if you do end up exceeding like the maximum PV power on a micro. It'll be the shutdown process or something like that.
Oh, sure. Yeah. So like the actual wattage, let me see. Was that posted in the chat? I don't see it. So we do recommend going up to a 1.3 DC to AC ratio. And I'll just step all the way back to the 1-in-1 page here, because it's a little bit easier to do the math if you're looking at single inputs. So let's say you're looking at the HMS 500. Based on the MPPT voltage range and the maximum input current, that will essentially only ever output 500 watts. And the continuous output is 475, although they can go above their continuous output in the right conditions. The continuous output current cannot be exceeded, though. So that makes it safe for the number of units per branch. But what allows us to do a higher wattage, like you see commonly used module power for the HMS 500, this microinverter can only ever output up to about 500 watts in the right conditions. But we commonly use this microinverter with PV modules up to 670 watts. So the important thing there is your PV modules have STC maximum output current of the PV module, which correlates to the input current of the microinverter. This maximum input current that we list on our spec sheet is actually not so much a guide for which modules to use as it is just showing that the microinverter will never pull more amperage than that from the PV module, from the solar panel. Meaning you can use a PV module with a higher maximum output current than the maximum input current of the microinverter, as long as the input short circuit current doesn't exceed, as long as the ISC, the short circuit current of the PV module, doesn't exceed the maximum input short circuit current rating of the microinverter. So essentially, if you use a PV module with a higher wattage than the microinverter, you'll get clipping, right? You'll have flat production during the peak production hours of the day, which is generally recommended. That's I think many people here would agree that that's a good and efficient way to design a solar system, is to have some clipping in order to keep the microinverter operating at maximum capacity for as long as we can throughout the day and throughout the year. Does that answer the question, do you think, Ian?
Yeah, that's basically like the total power rating is not super important. It is as long as you're not getting above that 65 volts. 65 volts, it'll shut
Yes.
down, and
Mm-hmm.
the short
And
circuit
the
current.
short circuit current on most of these microinverters, 25 amps exactly. So those are the two important specs that we use to determine if a PV module is compatible with our microinverters. Is the voltage that solar panel, excuse me, outputs, as well as the short circuit current rating of that solar panel. Those are the two most important ones. The input current of the microinverter is not necessarily useful at all in determining if a PV module is compatible.
Perfect. Thank you.
Okay. Yeah, of course. So again, here, this is sort of a more of a demonstration of the entire installation process. Pre-installation is going to be assembling your trunk cable. If you don't purchase pre-assembled cable, or I guess even if you do, you would still need to, like I said, remove the cable from the last section. Like after your last microinverter, you would remove the cable from that last T connector and put one of those plugs in here. You can just kind of see that right here in the upper left-hand corner where my mouse is. Second step is to fix the AC trunk cable to the rail. Typically, this is done with zip ties. And then install the microinverters next to them using your micro mounting bolts, whatever is appropriate for the rail that you're using. And then step 4, these microinverters have a short whip, about a foot long, that you would then connect into the T connector here. And make sure you get that click. There will be 2 clicks when you make sure that AC connector is snapped in correctly to the T. And then step 5 here, the AC end cable. This is the cable that goes back from the first microinverter in line to the junction box or Solodeck. You can use the cable that comes with the trunk cable, but you don't have to. If you need a longer length than what you can provide, than what our trunk cable provides, or if you don't want to, just use extra trunk cable if you don't need to, you can use. Commonly, people will use SJOOW, 10-3 SJOOW. I've been told fits into the weather-tight connector of our T connector here. Although I do recommend always taking one of our connectors to your supply house and making sure that your cable fits before you purchase any great quantity of it. I have had one customer bought a reel of SJOOW from a different cable manufacturer than what I was used to, I guess. The outer diameter was completely different, did not fit in the connectors, and he had to go back to his distributor and find a cable that worked. So I always recommend bringing one of these T connectors with you if you're going to be assembling your own AC end cable. Make sure that you get a cable that fits. We do have specs for that as well. The outer diameter, I believe it's 14 millimeter, but if you reach out to us, we can provide you that information straight from the source. And then step 6, anybody that's installed a microinverter system is probably familiar with this. You create your installation map. Each microinverter has a barcode sticker on it, has 2 barcode stickers on it, I should say. You peel one of those stickers off, place it on the map so that you know which serial number of microinverter is where on the system. And then you connect your PV modules. This is the point where the microinverters turn on. You'll see the LED light start to blink. And then you energize the system, turn your breaker on if your utility allows it. Otherwise, wait until PTO, obviously. Okay. So here we're going to start talking about the DTU, the communication device for our microinverter systems, for our HMS microinverter systems. We're going to use the DTU-Pro-S. We also have a DTU-Pro without the S that is not compatible, that is not compatible with the HMS microinverters or HMT microinverters. If you have HMS microinverters, which is what we're talking about today, or HMT, which by the way, the HMT microinverters, they're the three-phase version. They use 5-wire trunk cable and are slightly larger to accommodate the 208-volt three-phase that they're designed for. But for either of those microinverters, HMS or HMT, you're going to use the DTU-Pro-S because that is the DTU that uses sub-1 gigahertz communication. The DTU itself can connect to internet via Ethernet or Wi-Fi or 4G. We actually sell two versions of the DTU. We have a Wi-Fi version or a 4G version. Both of those DTUs have Ethernet ports already available. So if you're going to connect it with Ethernet, you're usually better off just getting the Wi-Fi version because the 4G version is more expensive. It comes with a data plan. I believe these still come with a 3-year data plan, although I've been told we also have 5-year data plans available. And if you ever have one of our DTUs that runs out of data on its prepaid plan, reach out to us and we can get you in contact with the right people to get you another SIM card for that. Let's see. We do support RS-485 and RJ-45 to communicate with other devices. Module level monitoring is provided by this DTU, and local configuration with the S-Miles toolkit through the S-Miles installer app. That's what most of our installers are going to be most familiar with. That allows you to get real-time data, voltages, production, communication, alarms, all that type of stuff. As well as remotely sending commands, upgrading firmware, changing parameters, things like that. And the DTU also allows us to do zero export management as long as we have a external meter installed. You'll notice most of our systems are actually installed without a meter, with the exception of what we're showing here on this page. Our combiner box is an optional accessory. It is not required for our installations. You'll notice this DTU is freestanding, sitting on a desk with 2 antennas. This is almost always installed just inside the home somewhere. The combiner box is the alternate option. So this is a load center with breaker slots and a DTU and a meter built in. So if you need production monitor, what would you say? Utility grade monitoring, I think it's called, or whatever. If you need the most accurate production values possible, say for local tax incentives or something like that, the combiner box has that built in for easy installation. So this combiner box includes a DTU-Plus and a smart meter. The DTU-Plus is slightly different, but in terms of functionality, it's exactly the same as the DTU-Pro. The difference is the DTU-Plus is mounted in our combiner box. And yeah, this makes for easy installation if you need production and consumption monitoring, compared to with the DTU-Pro, which is mounted inside the home. You're running a 2-wire communication cable and installing an additional meter accessory. It's not as easy as if you use the combiner box. So we definitely like the combiner box for those installations that need production and consumption monitoring. Here's a diagram and spec sheets, partial spec sheet for the combiner box. You can see we have 1 breaker slot used for the DTU, power supply, and the smart meter. We have 5 other breaker slots for microinverters. It's got PV production CTs pre-installed going up to the meter there. Obviously ground bar and main lugs and all of that stuff. There is an additional antenna included in the box in case the combiner panel can't be mounted close enough for stable communications. We have this external antenna that's included with it as well. Yeah, let's move on. And here's the DTU-Plus. This actually only comes in the 4G option, although much like the DTU-Pro, it does have an Ethernet port in the bottom, so you can hardwire it as well if you don't want to keep keeping up with the SIM cards every 5 years. Let's see. Yeah, it has the external antenna for consumption and load monitoring and stable communication and everything. We do like this combiner box, although, like I said before, it is optional. What many people would use in that place is just a standard generic load center, Eaton or Square D, whatever brand you prefer, and then have the DTU-Pro just mounted inside the house. Since we don't use power line communication, that communication device doesn't need to be mounted in the combiner panel, but it can if it's necessary. You can use our combiner panel, like I said, usually for consumption or production monitoring. Let's see. Yeah, here's a bit more spec sheet. So for the DTU-Plus, similar to the DTU-Pro, maximum communication distance in ideal setting is about 500 meters. So usually you're going to have stable communication in most scenarios. Now, real world conditions, 500 meters is probably further than what you would actually get stable communication, especially if there are any obstacles or anything like that. Wireless communications can be affected by a lot of things. The monitoring data limit for solar panels. So this spec confuses some people. And it's actually the same for the DTU-Pro-S and the DTU-Plus. Each DTU can only communicate with up to 99 PV module inputs, solar panel inputs. So what that means is if you have 1-in-1 microinverters, that DTU can communicate with 99 microinverters. If you have 2-in-1, that DTU can only communicate with up to 49 microinverters. If you're using our 4-in-1 microinverters, like the HMS 2000, only up to 24 microinverters can communicate with one DTU. But if you have more than that, if you have more than 99 PV modules on an installation site, you can just use more than one DTU. All the data gets integrated in the HMS cloud platform seamlessly. It all shows up on the same plans. Everything looks very good in that way. And honestly, having multiple DTUs helps to improve the communication on larger arrays anyways. Let's see.
Hey, Drift, just
Yeah.
had a quick question come in. I know we're
Yes.
focusing on the HMS, but somebody was asking if there is a three-phase combiner box, like for the HMT series.
There is not. We don't have a combiner box for the HMT series microinverters. Our combiner box is only single phase. But like I said, the combiner box is not required. If you're going to use HMT microinverters, you would just use any generic three-phase load center or breaker panel, and you would use the DTU-Pro-S, the exact same DTU-Pro-S that you can use on a residential single-phase system with the HMS microinverters. You use that on a commercial system with HMT microinverters as well. And especially to my point here about the limit on solar panels per DTU, 99 panels. Especially we find this on our commercial jobs that tend to be larger. You often have them spread out very far, and having multiple DTUs can help improve that communication, especially on large systems. You would have maybe one DTU on like the north end of the array or the east or west end of the array, and then another DTU on the other end if you have anywhere up to 198 solar panels. And that helps to keep stable communication. And the DTU-Pro-S is easier to move around. If you're using the combiner box, that combiner box is wired into AC. The DTU is integrated into the combiner box. You do have the external antenna you can install for better communication, but the DTU-Pro-S, much easier to place in a location that is going to work for more broad installation environments. It allows you to, as long as you have it in a weatherproof container, a weatherproof box, NEMA 3R or something like that, then you can mount it, at the array if it's a ground mount, or many types of different solutions. And then if it's far enough away from your internet source, your Wi-Fi, you would probably just run an Ethernet cable out to that as well. So good planning makes for easy installations.
A very related question from Wes on if there is a external antenna or something like that for the DTU-Pro-S.
That is a great question. We actually have them on our technical support team. We have external antennas for the DTU-Pro-S. They come in a couple of different lengths, 10-foot and 30-foot, I believe. And we don't sell them, but we provide them for free for any of our customers that need them on the after sales side. So our technical support team, if you come to us with a communication issue saying, hey, we've tried moving the DTU, we've tried everything, we can't get stable communications, we'll just send you an external antenna. We'll talk to you about which one fits your needs the best. Whether it's 10-foot or 30-foot or whatever. And we just send them out free of charge as an after-sales service. And speaking of communication issues, we also have another solution beyond the external antenna. For these HMS and HMT microinverters, for our newer series microinverters, we also have, and there's no slide for this because it's technically still in beta, although we're using it more and more commonly with very good results. We have a mesh network beta firmware that we apply. So by default, each microinverter, I don't think I have a good slide to show this, but by default, each microinverter communicates back to the DTU on its own. Each microinverter has to send its own data to the DTU. With the mesh network firmware, that turns the entire array of microinverters into a mesh. So each microinverter is communicating with the other microinverters, and then only the microinverter nearest to the DTU needs to have stable communications. So that's another solution that we've had really good success with, improving communications on systems using our HMS and HMT microinverters. We've had very good results with that beta mesh network firmware. Yeah, and we're right at the end of my presentation here now. So if anybody has any more questions, now would be a good time to get them in while I kind of look over some of these installations that we have on our slideshow here. I'll just talk about these a little bit. This one here on the left is located in England. These exact products aren't available in North America. I don't think they would be able to be approved with the way that this is wired up with loose cabling, but apparently they're able to do that in England. Our hybrid inverter looks slightly different from this in North America, and our battery also looks slightly different. This is a microinverter system in Malaysia using the HMS 2000. Pretty clean installation there, as well as over here in Canada. This is our North American demonstration photo, I suppose, showing again the HMS 2000 installed on a residence in Canada there. That's 17.6 kilowatts of solar. Let's see.
I had a couple more questions coming through the Q&A.
Yes.
Another from Wes who's asking if it is possible to enable the mesh, or is that something that's still kind of upcoming?
I'm sorry?
Like the mesh network that you were talking about.
Yeah.
Is that something that's...
Reach out to us. We have it available to us on the technical support team, Hoymiles North America. And if you have communication issues, just reach out to us and talk to us about what your issues are. We'll pull up your site and take a look. if it looks like the mesh network would be a good fit for your system, we'll get started working on that right away. And they are firmware upgrades that need to be applied to every microinverter. So it can take some time, usually a day or so, for us to fully finish those upgrades, but we're happy to do that for our customers. And like I said, if the mesh network upgrade isn't enough to get stable communications, then we do also provide those external antennas free of charge. So between the two, we really don't have continued communication issues with the HMS microinverters. Like I said, they already have greater communication distance and better barrier penetration thanks to the sub-1G communication. When you add on the mesh network and external antennas, which again we provide free of charge for systems that need them, that is, a very consistently good communication strategy.
Just on my end, is that going to be at some point the default, or will that continue to be something that is per job?
Yeah, that's a good question. We've had the mesh network firmware for probably at least a year and a half now, maybe 2 years. It's still in beta. I'm sure eventually it will be released stable. And, at that point, to my understanding, unless we do a mass upgrade of maybe a new series of products would maybe come with them from the factory, or maybe there would be like a mass command sent out to every system that needs it or something. More likely what would happen, I think, once that mesh network becomes a stable release, it will be available to installers to apply themselves without having to reach out to us. So if you have, let's say another year down the line, the mesh network becomes released stable. If you have a system that has poor communications, you would be able to click a button on the HMS Cloud platform and apply those updates without having to reach out to us. That's generally how our firmware release works. Is once the release is stable, installers gain access to them. But while they're in beta, only Hoymiles technicians have access.
Gotcha. That makes sense.
So yeah, these are some Hoymiles systems from around the world. None of these are going to be in North America because we don't have the very large utility scale equipment here. But they are cool to look at, and that is more or less my presentation. So if there's any more questions, let's see. Yeah, go ahead.
Yeah, there's one more. Just asking if you could briefly go over the commissioning in the app.
Yeah, I'll tell you what. I think let me pull up another slide deck for that. Give me just a moment. I can definitely do that. I didn't really think about how that slideshow didn't actually have very much information about the app. Let's see. I've got a document for that right here. HMS Microinverter User Manual app. So we'll start with this. Is everybody seeing this screen right now?
It's coming through.
Okay. Uh-oh, what have I done? Should have prepared better. Should have known somebody was going to ask about the app. So here's our user manual for the HMS Cloud app. We do also have HMS Cloud available as a web platform. You can see it here on the laptop screen here. This particular document focuses on the app. You can do essentially everything in the app that you can do on the web platform. So I'm gonna skip to, after you've logged in, this is all basic stuff. I'm gonna skip to creating a new plant. I think that's what most people are gonna be interested in. So in the app, it's very simple. Process is very similar on the web page as well. When you first log into the app, you're brought to the plants page. If you have any plants already created, they'll be listed there. If you don't, you'll still have this plus button in the upper corner here. Click on that plus icon to create a new plant, at which point you will put in the basic plant information. You'll input whether it's a residential plant, or a commercial plant or a large commercial plant. I actually, even for residential systems, I actually usually recommend everybody sets them up as a commercial plant, because it removes some guardrails. It allows you to do some more things. Until you get into it, you wouldn't really notice the difference. And you can certainly set up a residential system as a residential plant. But I like to tell people to go ahead and set them up as a commercial plant just to give you more options down the line in case you need to. And then after putting in the basic plant information, street address, capacity, the name of the plant, things like that, you have the ability to upload a photo as well. You would then create the owner for the customer. Essentially, you put in their first and last name and their email address, and you create a password for them. And that's pretty much it. You click next. And then that's where you start adding devices. You're going to scan in the serial number of your DTU first, or type it in manually if you prefer, although scanning is generally easier. And then after the DTU serial number is scanned in, you scan in your microinverters. And then move on to the layout page here. It's very easy to set up a simple layout in the app. With more complicated layouts, it's usually easier to do that on the web page. But in the app, it's very easy to do simple layouts. You basically just click and drag. The microinverters show up on the list. Like, let's say you have a 4-in-1 microinverter, an HMS 2000 or similar. They show up on this list here as their serial number -1, -2, to show each individual input separately. And you can maybe just barely make that out on this. I zoom in there, you can see this is a dummy serial number, but they're listed here. This is 2 separate 1-in-1 microinverters. Each one ends with -1, -1. That's how you know that they're both 1-in-1 microinverters. If they were 2-in-1, you would have a -1 and a -2, or -3, -4 if they were 4-in-1. Let's see. And then there's basic configuration. If you need export management, you enable it there. Power balance config is not actually used in North America. Our 3-phase microinverters are automatically power balanced. Let's see. The plant name, currency for the revenue calculations. You can put in the electricity price per unit, various other things. And that's pretty much it. And you click finish. And the document here goes into a bit more detail about export management and some of the other settings that you may or may not need. But it's actually a very simple commissioning process. It's really 4 steps. Basic plant information, creating the plant owner, adding devices, and setting up the layout, and then configuration, which most people just skip. Like, if you don't need export management, then there's maybe one or 2 boxes here you might check or uncheck before you click finish. Very simple process.
But a couple more questions. I'll start with the one that was related to this. Is someone asking, if they initially set up a plant as residential, can you swap that to commercial without losing all the...
You actually can't, which is, again, part of why I recommend creating every plant as commercial right from the start. And basically what that allows, the difference is the number of different arrays you can have. So on the app here, there's not much difference, right? Like I said, you can really only do simple arrays in the app when you're laying things out. But on the web page, it allows you to set up multiple arrays at different angles, azimuth, all kinds of different options. If you set your plant up as a residential plant on the basic plant information, you have fewer options for multiple arrays. Whereas if you set it up as a commercial plant, you have more options for multiple arrays. And that's sort of the major difference. And there is no way to change that after it's been set during the initial plant creation. So I always recommend setting up every plant as a commercial plant right off the bat.
Sense. There's one more from Wes. Is just asking if there's any kind of like online resources for common problems or like frequently asked questions before having to go to tech support. Just if there's something that's like a known firmware issue that mentioned you had to deal with before.
Yeah, honestly, I can't think of much. We do have all our user manuals are available online at hoymiles.com. The most user manuals are going to come with a troubleshooting section showing, certain common issues and what to do about them, maybe what the LED lights indicate and things like that. But to be honest, I would recommend generally just reaching out to us. If you have trouble with an issue, you're not familiar with it, give us a call. We're really quick to answer the phones. Usually within 5 minutes or less, we'll pick up the phone. Almost nobody ends up waiting longer than that. And if you do end up waiting longer than that, we'll give you a call back as soon as possible. Or reaching out to us via email. If it's something urgent, calling us will be the best way to get a quick response. But reaching out via email will definitely get to you within a few hours. If it's during our business hours, you won't wait more than probably 4 or 5 hours to get a response on an email during business hours. If you need something faster than that, give us a call. We're quick to answer on the phones. Speaking of, I realize now that our contact information is not anywhere on this slideshow. So I will read that out loud, and I'll probably also post it in the chat here as well for anybody that needs it. Our technical support hotline for Hoymiles North America, the phone number is 205 395 5515. And I've just posted that in the chat as well. And our email address is support.us@hoymiles.com. Oh, no, I'm sorry. Ooh, I need coffee or something. Service.us@hoymiles.com. Service.us@hoymiles.com. If you want to reach out to us via email, you can open up a service ticket that way or give us a call.
And that is all the questions that I see open, and that is very good timing.
Perfect.
Perfect. Well, Jeffrey, we appreciate you joining us today. And Ian, thank you
Of
for
course.
fielding questions. Thank
Mm.
you to everyone who attended today's session. This webinar will be sent to all of you by the end of day today, and it will also be added to our YouTube channel, which I will also add in the chat for you. There we go. So yeah, that concludes today's session, and thank you again for joining, everyone. Have a great rest of your day. Take care.
Thank you.